Hey guys, this is Independent Lesson 1.4, describing distributions of quantitative variables. Now, most of what we're dealing with is going to be using an acronym, and we're going to get to that. However, I think it's very important to spend some time on these first 5 definitions here. The symmetric distribution, which is always going to look something like again, the definition of symmetric, I know that's not 100% perfect, but it kind of has the same shape on both sides. That's probably closer to it. Symmetric distribution, left skewed tail, exactly like it sounds. It's going to have a nice long line on the left side, and then I'll have the peak. And right skewed is the exact opposite of a left skewed. It's just going to be reversed. Unimodal distributions, when it says it has one distinct peak, that's the exact definition. So it could be actually any one of these where it has only one little peak. However, bimodal distributions, and we usually only deal with 2 peaks or bimodals, they'll have, one little peak of data there, maybe a gap of data, and then another peak somewhere. So it'll actually have 2 distinct peaks, 2 little big bars of data, whatever the case. And we have our measures of center here and resistance of those measures, range, standard deviation, IQR, 1.5 IQR. The only one I really want to focus on is the range. So when it says that it's the difference between the largest and the smallest data value, really you can just do your maximum number minus your minimum number, and it's going to give you the range of data. And that is what we're going to be using for our measure of spread today. The other things, standard deviation, IQR, and the 1.5 rule, those are things we're going to talk about next week, not something we're really going to worry about today. And this is where we're really going to focus the shape, center, spread, and outliers. This is the acronym that we are going to be using to describe distributions, SOX. You could switch around the S's if you want to, but this is just the easiest way that I have found to remember these. So first off, we will determine the shape. That's just the order, again, I like to go in. You could go in any order you'd like. So describe it as symmetric, left skewed, right skewed, or it can be unimodal, so it has 1 peak, bimodal, 2 peaks, or approximately normal, which we haven't actually looked at yet. So distributions that are approximately normal, again, you've got your x-axis down here. Your uniform distributions are going to be looking like a nice rectangle, just kind of dropping flat off of one side, and a flat top as well. Nothing super weird or crazy about those. And we'll look at center. Either mean if it's roughly symmetric, no outliers, or skewed with outliers, we will use the median. Those definitions, remember, are up above. Mean is the average, and mean is just the actual middle value. And it's got sort of these diagrams here where they kind of fall in between these 3 different shapes. And those are things we're going to go over more next week, again, when we actually talk about these data values and calculate them. Spread, just like I said up above, we're really only going to be using range today. Standard deviation, IQR, we're going to talk about next week. Outliers, we're just looking for things that are outside of pattern, something that look different from what's shown in the big graph. We're going to talk about mathematically how to find them again next week, and that'll take us to our examples. So we are going to describe the distribution in complete sentences using SOX. Remember, SOX is looking at the shape, seeing if there are any outliers. looking for the center, whether that is the mean or the median, and spread. So for us, that is going to be the range. So the shape of this one, it's always easiest for shape to sort of just draw a little blanket curve over the top of the graph, not really paying attention to all the little bumps, because that's going to really kind of mess it up for you, confuse you a little bit. So just a normal blanket curve. And we'll start off our sentence by talking about the shape. So we know that the distribution shape is, and if we look at that purple line there, notice how it's very, very much like a bell. And because it's a bell curve, that means that shape is symmetric. And since it is a symmetric shape, that means we can use the mean and let's see, the mean, which would probably be our peak, is right around here where that big tall bar is, which means it has a center at around, and this is where we need to do some guesstimating because we don't have the actual data points in front of us, so we don't really know. But it's in between 9.5 and 10.5, so it's probably a mean of around 10 because of this. And if you look, there's no actual data points that really look funny. Everything sort of falls within this increase on the inside and decrease on the outside. So we can probably say that there are no outliers in this distribution. So we talked about shape, the center, outliers, and all we need to talk about is the range. So the range, remember, we can do the maximum or the biggest number minus the smallest number. So here we've got, if we had to guess, I'd say our maximum is about 13 and our minimum is definitely 6.3. Again, that maximum is an approximation. Because we don't have the actual data points, if we had those, it would be much easier to figure this out. So if we're looking at that subtraction there, 13 minus 6.3 gives us a range of 6.7. So we're looking to just check and see that we've talked about everything we need to talk about. Let's see, we've talked about shape, determining whether it was symmetric or not, outliers. Let's see, we said how there was nothing that fell out of pattern. Center, talked about how that center was around 10, where that gap is. And last but not least, our spread is talking about our range. So as long as we sort of mentioned all four of those things within our sentence, we've completely, accurately, and to the AP guideline standard described this distribution. So let's look at the second one here. And I'm going to go in the same order for all of these. Shape, well, I know I went backwards for the other one, but I'll generally go in this same order at the top: shape, outlier, center, spread. So let's look at the shape. So again, it's really easy when we are looking at shape to just sort of draw that blanket curve. And it doesn't have to be super accurate, just enough to, get a general picture. And in fact, I'm actually going to redo that just so we can get a sense of the actual dip between everything. And this was something we talked about on that page with the definitions, where if we have something that has a little bit of a dip in the middle or maybe a gap in the middle, that's something called a bimodal distribution. And just like the one up above, there's nothing really that falls out of pattern other than the fact that it's weird to have that dip. It's weird to look at. but we can't mathematically prove that there are outliers. So we can just go ahead and say for now that there are none. And our center, since there's two peaks, we need to talk about both of those peaks. So those peaks are at about 42 and maybe 60. It's in between 56 and 63. So it's around there. So 42 and 60. And all that's left is the range. So again, we don't have the actual data points. So it's very hard to determine what these actual numbers are, but we can approximate. So we'll say that the range is approximately, well, we know that the smallest number, it's kind of sitting out there at the left, but it's about, we'd say maybe like 25 or 24 or something like that. And our maximum would probably be closer to 80, maybe 78. So we can say that our range is about 78 minus 25. Again, those are just approximate numbers. So that'll give us a range of 53. Again, if we had those individual numbers in front of us, we would be able to find this a little bit more clearly. And we only got 3 more here. So let's look at this one on the very top. Once again, starting with the shape. So the shape of this distribution, again, we can easily find that out with a little blanket curve over there. It does sort of dip off to the left, but it's not really big enough so we can notice and care about it. We really care about the fact that there's this sort of lingering tail over here on the right. And because of that tail that is hanging out on the right, that means that this distribution's shape is a right skew. So since it is right skew, we are looking at a center of the median, but let's talk about the outliers first. We do have this little gap right here. We don't know if there's any outliers. So with the gap, we have to talk about this gap that is at 45%. So that means there is a possible outlier at approximately 47-ish%. It's about between 40, it's in between 45 and 50, so we can kind of guesstimate a little bit out there. Since it is skewed, like I said, we need to use the median. The median is generally going to just sit in the very middle of the distribution, but it's also going to sit where most of these data values are carried. Remember, with the skewed, that median is sitting like right in the middle of the peak. So it's about right here almost is where our median's going to be. So the median, our preferred center, is going to be about, again, we need to approximate here. It's in between 25 and 30. So that means it's about 27%. And we're dealing with range again for our spread. So our range of let's see, we're dealing with a maximum of, again, let's say 48%, just to be on the safe side, and minus, well, our smallest value is probably about 16 or 17, so that's going to get us a range of 32. And again, these are all approximate numbers. They're not necessarily exactly equal, but doing all of this together is going to give us our socks. Continuing on here, again, starting off with the shape. So we'll talk about the shape of the distribution. And we'll look at that blanket curve. So notice there's that really big gap there in between 2 and 10. And we will talk about that. However, the fact that just like the one up above it, there's this very obvious tail hanging out to the left. That tells us our distribution here is left skewed. And because we have these two data points out of pattern, the ones sitting right in between 0 and 2, that means we do have some possible outliers here. Mathematically, we're not sure, but we can safely say that they're possible outliers. And they're at 0 and 1, just because, remember, with histograms, wherever that far right side of the bar touches, it's always 1 less than that value. And since it is skewed, again, we want to look at the median. For us, the median is going to be sitting sort of maybe right in there, sort of where the peak starts to taper off, gets at its highest. So a median around, and it's in between 12 and 13, or 12 and 14, if you notice that. So we can say that the median is around 13, and a range of, well, our max is definitely 13, and our minimum is 0, so that's going to give us an exact range of 13. This last one is a very simple one. If we're dealing with the shape, again, notice how when we draw that blanket curve, it's very sharp edges, just like a rectangle. So when we were looking at the vocabulary pages, and in particular the specific section on shape, anything that sort of has that rectangular shape, that means the distribution is uniform. That is our shape. Since there are no gaps, nothing that really falls out of place, we can definitely say that there are no outliers for this data. And since everything is definitely equal and symmetric, our center will fall directly in the middle of our graph here. So that's at 2.5, since it's in between 2.4 and 2.6. And our range, notice how it goes from 3.0 to 2.1. So there's only a difference of 1 in between them. So that's from doing 3.0 minus 2.0, which will get us that range of 1. So all these different types of problems should help you to be able to describe shape for any sort of graph that we talk about. If you guys have any questions for me, please let me know. Please send me a message, email me, and I'll be happy to answer. Thanks, guys.